is simplify. Simplify means about 1/100 to math. If you have simplify and it's a fraction, you know you have to write it in lowest terms. Simplifying with a fraction with a square root on the bottom, oh, when it's simplified, there's no square root on the bottom. There is so many things that simplify means, and now we have simplify with logarithms. Simplify with logarithms in all of your log formulas, and I have them up on the board and they're on your formula sheet. The left-hand side is considered the simplified side. The right-hand side is considered the expanded side. So if we want to simplify, sometimes the simplified in questions is written as right as a single logarithm. And it's considered more simplified than others. So in part A, we have a log plus a log. First thing I notice is that no base is written in either of those logs. So that assumes a base of 10. So when a log is written by itself, it assumes a base of 10. And since the bases are the same, and this is important for log laws, all of your log laws on the right-hand side, if you're adding, subtracting, or multiplying, they all have the same base. So this would mean I'm allowed to write this as the left-hand side as log of 7 times 8, which is equal to log of 56. Part B. I see a number outside of the logarithm, and we're multiplying. That is our third log law. And our third log law says anytime you have that number in front, you can move it back inside the logarithm as an exponent. And then 2 to the 5 becomes log of 32. And then in C, log of 80 minus log of 16. Again, all of these are base 10, but the bases have to be the same in order to use the log law. And 80 divided by 16 simplifies to 5. So if we can write things as a single logarithm, that is considered simplified. I'm going to add a part D. And I'm going to add 3 things, and I'm going to reintroduce you to the natural log. Because I'll tell you, once you get to calculus, you will use almost exclusively only natural logarithms rather than logarithms. Adding means multiply. The bases, do you remember that the base in the natural log is the number e? Just like log by itself, when no base is written, is a base of 10, natural log assumes a base of e. But it happens so much that they just use natural log instead of writing out log base e. So these two right here, we're adding with the same base, so I could combine those together with multiply. And now I'm subtracting with the same base, so I could combine those together by dividing. And I am perfectly fine if you go and do those steps together. If you have multiple adding and subtracting ones, in fact, I often prefer if you do it all in one step. Notice whatever's added got multiplied together in your numerator. Whatever is subtracted is going to go in your denominator because you're going to divide. So if I do, I'll add one more question. Let's say log base 2 of 5 minus log base 2 of 3 plus log base 2 of 7 minus log base 3 of 6. I would expect you to be able to do this all at once. Which ones are added? The 5 and the 7. 5 times 7, 35. Which ones are subtracted? The 3 and the 6. Those will be both in my denominator. 3 times 6, 18. I would go directly to that answer, yes. Oh, it should be, yes, good point. I got ahead of myself there. You're right, I would not be allowed to do that if that was a 3. And I meant to make them all 2s. I got excited with the question. Yes, so the bases would all have to be the same. With that base of 3, that would have been something you would not be allowed to put together. And had that been a base of 3, you would still have to write minus log base 3 of 6 at the end and couldn't combine it with anything. Okay, questions on this one? Circle questions 4 and 12. Oh, unknown error.